Hi guys, I am Kamalpreet Kaur from Women Who Code Delhi and we welcome you all to our new series Tech Bytes. I'll be going to talk about machine learning concepts in this series. In our first lecture, we'll be going through a brief introduction to machine learning. In this lecture, we'll be covering what is machine learning and how it works in a broader sense. Then, the different approaches, or we can say that type of machine learning that includes supervised learning, semi-supervised learning, unsupervised learning, and the last reinforcement learning. Lastly, we will have a look at some useful applications of machine learning. So let's get started. Now, what machine learning actually is? Machine learning is an approach to data analysis that involves building and adapting models which allow programs to learn through experience. As we already know that data is a key on which machine learning relies. Even in the figure, we can see that the data is fed into the system with machine learning capability, and the algorithm or model we implemented on the system learns from the experience it gets from the data, predicts the outcome through model, and the most important nowadays, it improves itself. Let's have clarity if machine learning is a branch of artificial intelligence or vice versa. Artificial intelligence is the ability we give to the system to learn and respond like humans, whereas machine learning is an approach to design artificial intelligence system or machines. So, machine learning is a subset of artificial intelligence. Deep learning is a further subset of machine learning in which artificial neural networks adapt and learn from vast amount of data. We have already seen that machine learning is divided into 4 subcategories, that are supervised learning, semi-supervised learning, unsupervised learning, and the last reinforcement learning. So firstly, we will have a look at supervised learning. This is the learning type you will most likely encounter, as this is the most practical and widely adopted form of machine learning. In this approach, the model has to be given a labeled dataset, which means we need to feed both the input and output parameters beforehand to train the model. Once the model gets trained, it can start making a prediction when new data is given to it. Supervised learning is further broadly categorized into 2 types of models on the basis of expected result. First, classification. Here in classification, we want a category to be the output. We have 2 or more categories in which the output is classified. So, the output is discrete or categorical variable. Suppose we have a data set of images of dogs and cats, and we will feed input, or we can say that features, and output, that is dog or cat, that becomes label. Once the model is trained, the label for a new value will be predicted from the categories according to the features it exhibits. And the next comes regression. In regression, the outcome will be a real or continuous value. Suppose we need to predict the air quality index from the past information or the features that in some way impact the air quality of a particular region. The predicted result will be a continuous value in this particular scenario. Hence, this is regression. We can conclude from this that the main difference between classification and regression is the output variable in regression is numerical, while that for classification is categorical or discrete. Now, let's have a look at one of the most popular use case of supervised learning, that is Gmail's functionality of spam email filtering. In this functionality, the coming new emails are classified into not spam and spam emails. So we have a labeled dataset that is to be given to the model to predict whether the email is spam or not. Suppose in general scenarios, the emails that have large number of recipients are spam emails. So here the number of recipients is the feature or input variable, and the tag spam or not spam is the label or target variable. These type of features are mapped to the labels to train the model. After that, when new email comes and shows similar features like the emails categorized as spam will be marked as spam email. This is how the simpler algorithm can be useful in real world scenarios. Next comes semi-supervised learning. Semi-supervised learning is similar to the supervised learning except the fact that in the training data, the limited amount of data is labeled. That is, small portion of data has labels. For example, in image recognition, we may provide images that have labels containing objects we wish to identify and then process many more unlabeled images during the training process. Now comes unsupervised learning. Unsupervised learning is very much opposite to supervised learning. Only the input or features are given data, that is unlabeled data set. Instead, our algorithm would be fed a lot of data and given the tools to understand the hidden patterns or properties of the data. From there, it can learn to group, cluster and organize the data in such a way that human can extract or sense something out of it, that is newly organized data. So here in the example we can see that we have different type of images, different animal images as the input data that is segregated by the clustering algorithm of unsupervised machine learning into different groups. That is, it has made different clusters on the basis of similar features it shows into the different groups. So this is unsupervised learning. What makes unsupervised learning most interesting is the fact that most of the data in this world is unlabeled. Having intelligent algorithm that can take this amount of data seems to become huge source of potential profit to many industries. The last type of machine learning approach is reinforcement learning. Reinforcement learning is somewhat like hit and trial technique that enables an agent to learn in an interactive environment by using feedback from its own actions and experiences. Place a reinforcement learning algorithm in any environment, it will make mistakes in the beginning. We can reinforce our algorithm to prefer good behaviors over bad ones until we provide some sort of signal to that algorithm that associates good behavior with positive signal and bad behavior with negative. For any reinforcement learning problem, we need an agent, an environment, and a way to connect both through a feedback loop. The agent is connected to the environment with the set of actions we give it to perform in the environment. To connect the environment to the agent, we have to issue two signals, an updated state and a reward to compute the behavior whether it is good or bad. Let us take an example of the game Mario, where our agent would be our learning algorithm and environment is the game. More specifically, we can say that the level of the game. Our agent has a set of actions that are buttons in the game, that is up, down, left, right. Our updated state will be each game frame as time passes, and reward signal will be the change in score. As long as we connect all the components together, it constitutes as reinforcement learning scenario. So a feedback loop is formed that will go on until the agent wins the game or try to win it in lesser time. Let's have a look at one of the most popular use case of reinforcement learning. So reinforcement learning is basically used in gaming. So in recent years in chess, AlphaZero, that is Google's DeepMind project, defeated the 2016 TCEC Season 9 winner, that is Stockfish. It is a very strong and very powerful chess gaming engine, winning 155 games and losing just 6 games out of 1000. AlphaZero's creative insights give the confidence to build general purpose learning systems that will one day help find novel solutions to some of the most complex scientific problems. Now let's come to applications of machine learning. So first is predictions while commuting. Firstly, we will see travel predictions. Through GPS navigation services, our current locations and velocities are being saved at a central server for managing traffic that are used to build a map of current traffic. While this helps in preventing the traffic, the problem is that there are less number of cars that are equipped with GPS. Machine learning in such scenarios helps to estimate the regions where congestion can be found on the basis of daily experiences. The next important use case of machine learning is online transportation networks. You might have encountered surge pricing where it says that the fare for your ride has been updated. Continue anyway, and you say, yes please, I am getting late. That's an interesting application of machine learning. Uber and other apps use predictive models or algorithms to define price surge hours by predicting rider demand on the basis of number of cars available, bad weather, rush hour in real time, so that if you really need a car, you can get one. Moving on to the next, we have fraud detection algorithms that are widely used in the finance sector, in which we need to find the fraudulent transactions out of huge amount of transactions data. Next, self-driving car, that is another popular application nowadays. In healthcare sector, machine learning algorithms are helping doctors in diagnostics in efficient manner. Now, let me give you a task. In this task, you have to figure out whether the following scenario uses supervised or unsupervised learning. Case 1. Bank decides to distribute loans on the basis of customers' financial history. Case 2. Spotify recommends tracks on the basis of other users who have already listened it. Case 3. Analyzing the bank data for suspicious looking transactions and flag them illegitimate. Comment your answers in the comment section below. In this video, I hope you got an idea that what that buzzword machine learning actually is. Thank you for watching the video. See you guys in the next video. Till then, take care and keep coding.